see that, and we should be prepared for the invite. Or if you want to share something before that, please let me know.
Yeah. Just hold on. After 1 or 2 minutes, you may say.
Okay.
Just start. Good evening, everyone. I'm Professor Viru Rajak, convener of this webinar. Welcome you all on the behalf of our team, Asansol Girls College. Today, I am very much excited. Excited for the reason. Today, session is based on very emerging topic, that is data science. As we know, data is one of the important features of every organization because it's help business leader to make the decision based on fact, statistical number and trends. Due to this growing scope of data, data science came into the picture, which is multidisciplinary field. It uses scientific approaches, procedure, algorithm, and framework to extract the knowledge and insight from the huge amount of data. Huge amount of data in the term of as a big data. Big data analytics is going to change everything. We are really looking at the new paradigm, a place of data primacy where everything starts with the consideration of data rather than consideration of technology. So in this webinar, we will also learn how to analyze the data with the current scenario and the data set. To discuss over this, I would like to call our eminent speaker. But before speaker, I would like to our Vice Principal, Sir, Dr. Sandeep Kumar Ghatak, to say something about the college. Sir, please.
Thank you, Biru. Very good evening to all. I welcome on behalf of the Asansol Girls College to this webinar organized jointly by Internal Quality Assurance Sales and the Department of Computer Science of Asansol Girls College. Especially, I am thankful to the speaker who give us valuable time with us today. And I think this seminar will be more interactive and interesting, as just now Professor Viru Rajak has told us that data science is very much important in the present context. So it is my perception that the participants who are joining this webinar, they will be benefited from the speeches given by these two most eminent speakers. And our college, that is Asansol Girls College, is one of the pioneer college under the Kaji Nazrul University, and it is regularly exercising intellectual activities. And as a part of the intellectual activities, this webinar we organized today. Those participants who participate in this webinar, I convey my thanks to all the participants, and also gratitude especially to the speaker who speak today and enlighten ourselves about the most relevant and important topics. Thankful be, without wasting much time, we should go to the speaker and we invite them to this webinar platform so that they can enlighten us about the topic. Thank you, Bill.
Thank you, Dr. Ghatak. Now we will move toward the further. I would like to call Mr. Neeraj. Mr. Neeraj is a senior software engineer. He has more than 10 years of experience in the field of data science. and software engineering. He has worked in different MNCs and different platforms with the edge-cutting technology like big data, Hadoop, Databricks, Congons, PySpark, Teradata, DB2, Oracle. Currently, he is currently working in US with one of the four big consultancy firms as a delivery lead to implement the advanced analytics data modernization initiative. So, without wasting any time, I call Neeraj to start the technical session, and I hope that you all will enjoy, learn, participate in the lively question and answer session with our speaker. Welcome, Neeraj. Welcome once again.
Thank you, Professor Rajak, for such a lovely.
Uh, Neeraj, by mistake, you are on mute.
Please. Are
Yeah,
you able
now
to hear
it's
me now?
yeah. Okay, Neeraj.
Perfect. So thank you, Professor Rajak, for giving us such a lovely introduction, and Mr. Gatak for explaining everyone like how important data science is. And in this webinar, we will be focusing on that. And I hope to make everyone understand like how we are contributing to the real world in the problem what we are arising. Starting in different domains, starting from medical sciences to all the different domains, agriculture, food, banking, big data applies everywhere. And it's a very different scenario to tell you like we are the generators of the data. So this is quite interesting. So we'll go through it. Let me start sharing my screen, and I will start with the webinar with this presentation. So kindly let me know once you guys are able to see my screen.
Yes, Neeraj, it is visible.
Perfect. So this is our first introductory slide. And what we are doing in this particular webinar is we are moving toward the big data and the data science. And it's a buzzword all across the world, like what is data science? So we'll first understand what is data science, understand what is required to be a data scientist. Then we move forward with the data, how data is being used, why big data is considered to be a problem, what has happened in the past, and then moving forward with what we can do with it. And that's the most important part. In this particular journey, I will be also explaining you how to use the data so that we can understand how to get the meaningful insights out of it. And that can be applied uh, anywhere in any domain. So before I start, I do have a scenario. So let's discuss about that. So the scenario is, we all know as per the current situation, which is COVID-19, we all are in a lockdown phase. We cannot go out. The reason being the spread of virus, and it's negatively impacting us. So there has been some questions. And if you see, these are real world questions. Like kids always want to go out and play. So what happened is a set of people representing every continent, they reached out to us asking, are they safe to go out and play? And that was a very big question, because we have to answer that not only so that they can play, but our future depends on it. If our kids are not playing, that is something which is concerning. We are not able to provide a good environment. So this question looks pretty abstract, but once we go forward in the course, I believe we all will be able to answer this question about the kids. Like, are they good now to go out and play? But before that, I'll give you a background about what is data science, how it is done, what takes to become a data scientist. Moving on to the second slide. So what is data science? This is one of the most important questions which has been asked. And I'm pretty sure you can find the answers uh, once you type in the Google, but it will come with multiple answers and then you will get confused. So in order to simplify that, I'm going to tell you what data science is, what my understanding is, and what most of the people understand is. So it's a part of, you can say, in the right bottom corner, you can see we have artificial intelligence, which is a bigger subset. And under that comes machine learning, I will explain you in the later sessions in these webinar what are machine learning. And there are some specialized learning called deep learning, and this is done through machines. When we say machines, it's the computers. And when we combine math, statistics, visualization, and analysis, that small portion, the intersection of AI, machine learning, and deep learning is called data science. This might be a bit confusing. I agree to that because not everyone understands what these terminologies are. So if you see to the left of it, we have listed down statistics, data analysis, and machine learning. Now, machine learning is based on algorithms, and I will talk about that. What is machine learning? Statistics, we all know, we have studied the basic mathematics in which statistics was introduced. I studied when I was in my preliminary school. So it includes graph, charts, histograms, bar graphs, all those. Data analysis. Data analysis is, everyone understands what it is, like taking a look to the data and deriving and analyzing it to figure it out what is going. And then comes the machine learning. I have covered the machine learning in a much detailed way in the next slide. So let's talk about what are algorithms. So algorithms are set of instructions given to computer based on which it does its computation or its analysis or analytics. So let me move forward and I will explain you the machine learning piece of it. But before that, let's understand what a data science life cycle is. By this time, I believe everyone must be having understanding what data science is. But now we will discuss what data science life cycle is. When we talk about, yes, we are doing something in data science. So the question arises, what should we be doing? What we are trying to achieve? And why I should be doing it? That's a very preliminary questions. And yes, this is how we define a problem and solve it. We will take the example of the business case of the kids who asked us a question, are we safe to go outside and play? And then with this life cycle, we will be deriving a solution so that we can give them an answer whether they are good to play, go out and play or not. So starting with that, if you see the wheel, the first thing is, point number one is business understanding. So this is about asking the right question, defining the objectives. So before any of a particular analysis or a data science project, you need to set up some expectation, like what is required. When we say what is required, this question might be differ for many of us. Like in the kids' case, they wanted to go and play outside. For us, it could be when this COVID is going to get over, or when the drug is going to come into the market. We can answer these questions with relevant facts and relevant data if we have. So first, formulating the business understanding is the most important part of it. And this happens in every of the problem statement. So defining the problem statement is going to be the key part. The same thing has been elaborated in the right-hand side of it. So if you see the data science process, the number one is setting the research goal. What do you want to achieve by that? That's the first thing. And you can see there are a few subsidiaries with each of these tasks, like defining research goal, creating a project charter. So I won't be covering these because this will go in much more detail and it's not very relevant at this point of time. This will be only applicable and relevant when you start doing a particular project in data science. I mean to say, when you start looking for answers, so you have to outline the steps in a detailed manner, what needs to be done. So once we understand what the problem is, then what we go, we start taking a look to the data mining piece of it. What data mining does is, it's very similar to, in normal terms, finding gold. You do mine something and find gold. That's what it means. So here we gather and scrape the data necessary for the project. Like there is abundance of data, but what to pick? where to start the analysis from. That's the key point. And that's where the data mining comes into picture. I'll just take a pause here for a moment. I know many people might be having some questions and they're raising their hand. So we will tackle the questions at the end. You can ask the question then. So let us finish this piece in lieu of time, and then we'll get back to the questions. So data mining is something what we said. Next comes the data cleaning. It's very similar to once you figure out gold from earth, it's not like you will start wearing it. Obviously, you have to clean it and process it. The same manner we have to clean the data. There will be a lot of inconsistencies. And when we say a lot of inconsistencies, I will explain you what it is. Taking an example. If someone sends an email to you, not every line has some meaning. There are few specific lines which are really important to a person or the recipients or a different group of stakeholders. So we'll have to filter those out. The unwanted things needs to be moved out. Or take an example like you have data in terms of flyers, what you get. So as far as I remember, the flyer which has been distributed to every one of us, the most important data in the flyer was venue, time, and the topic. So obviously that's how we filtered it in our mind, and we realized this is what the data, what we want. So that constitutes the data cleaning. Once the data is clean, we move to the fourth step. That is called data exploration. When we say data exploration, like we need to figure it out. What do we have in the data? How it can help? We can define a hypothesis. Hypothesis in the same thing is like assumption, and then start working on it. So that's what the fourth step is. Then comes the fifth is feature engineering. Feature engineering, you won't see it here in the right hand side of it, because it is something which is very specific to certain use cases, and that will be converting the data into a different structure, or you can say a different model, but it is case specific, so you won't be taking that up. So next comes the predictive modeling. Predictive modeling is the way what we do is based on the data set, we do predict something like what is going to happen, just in case if we know in last 10 years what has happened and what is going to happen in next few years. So we can predict few events. Taking an example, we all know monsoon comes in India in June. How do we know that, and how weather forecast is done based on that? Like this year monsoon is going to come in India around July, or say they always predict that. And how do they do that? It's based on the data and the facts what they have received earlier. And the last step, and this is going to be the most important part, whatever your findings are, presenting to the audience. And that's the way to create the visualization. And when we say visualization, it will be in terms of charts, bar graphs. I'll be implementing the same life cycle on the problem what we have just seen about the kids, and we'll take it from there. So I hope this is pretty much clear. Let me move to the next slide. Now, as I said, we'll be discussing on the machine learning piece. So definition wise, if we talk about machine learning, is a study of computers to ability to understand how they will be handling the scenarios without being explicitly programmed. This sentence is most important, because right now what we know is in order to get a task done, you create a program every time. But machine learning is where computers understand what needs to be done. And I will give you some specific examples to understand that. But before that, let me explain you in what categories it has been defined to. Supervised learning. In a supervised learning, we tell machines what to do. So we do have a data set there, and we divide that into 70 and 30 ratio. 70 is for training the machines. Like in case you see this, this needs to be done. All the cases will be defined. And next, In 30% is the test data, and they will tell us what is going to happen if a new data comes in. So it's more like, teaching a kid how to pick it up and how to move forward. The very good example, the real life example, what you will see in the supervised learning is everyone uses Amazon or Flipkart. And you might be seeing whenever we order something, something pops up. Based on your last order, this is recommended. So how that recommendations are done? This is done based on the machine learning algorithms. That falls under the supervised learning. Next comes unsupervised learning. Unsupervised learning is a method where we don't specifically tell the computers what to do. We don't train them. What we do is we form groups. Take an example. It's more like a set theory sort of a thing. When we say set theory, like say out of 100 people, 20 drink coffee, 10 drink tea, and 7 to drink orange juice. So next time a person comes in based on their trait, and we have already defined the clusters, that's what you call clusters and classification. So we classify and create clusters so that when a new person or a new item is being introduced, computer can quickly tell like where it should go. And one practical example will be, suppose a person wants to buy a house and he has a particular budget in his place. So what is going to happen once he reaches a computer for the best optimal solution or recommendations? It already have multiple clusters defined based on the characteristics. And that's how it will be redirected to a particular cluster, and then it will be taken from there. So that's how the recommendations are done in the unsupervised learning. And then moving to the reinforcement learning. You might have wondered like how robots learn how to walk, or how robots learn how to go to a different planet, gather samples, because they can always see the unknowns and we are not aware of that. So reinforcement learning is a method in which computers and robots, they learn based on their actions, their decisions. And there are multiple games in the market also, which, based on a particular action, it redirects it, how it is done. So this is what machine learning is. And there are, obviously great details to cover in it, which cannot be covered in one session or two. It's something which someone needs to, work in it and move forward. So moving on to the next slides. Now, the question will be in everyone's mind. We do understand what is a data scientist is and what a data science is, and what should we doing, like what we can do to become one. So obviously that's a really great question if someone has in its mind. The first thing what everyone should know, knowledge of the machine learning. Machine learning, I just explained to you what is those. Next, strong knowledge of Python, SAS, R, or Scala. So what are Python, SAS, and R, Scala? These are the programming languages. So you need to interact with computer. In order to do that, you need to know some programming languages. And why these specific ones? In the data science world, if you see the small bar here, 54% of all the data scientists uses Python. It's a very strong tool. It's very easy to understand, but what it has so many modules and support, like it really helps them achieve that. R, which is 45% of the share, which is used by the statisticians. And the reason being they are not very I won't say it's a complex, but it has a different genre altogether where they focuses more on the statistical part. 36% SQL, and I believe most of us are pretty much familiar what SQL is. SQL is structured query language. If you have a database and you want to query some information, that's where you can get it from. Then come 19% for MATLAB. MATLAB is again a mathematical tool, 18% Java and 8% C++. I personally use Python and I like it. Now, next step, what they should be having in the hands-on experience in SQL and database coding. So they should be able to interact with the computers. That's what the intent is. Next skill set is ability to work with the unstructured data from various sources like video and social media. So as I said, data can rely in multiple platforms. So they should be pretty much aware of what and how to extract the information. So this is another skill set. And then understanding the multiple analytic functions. When we say this, there are some readily available functions which they should be knowing how to use that. Like we do have linear regression model in machine learning and regression analysis. So there are some pre-built models and they should be knowing how to use it. So it will give an extra edge to them. If they don't know it, they will have to start from the scratch. They may have to, user define it and then move forward, but it's always good to know. And if you see the right of the screen, I have mentioned it in a more detailed way, how it needs to be, incalculated based on the data and the skills, what they should be having, like maths, programming and databases, domain knowledge, and communication and visualization. Out of everything, as everything is important, but again, I'm stressing on communication and visualization. The reason being, it may happen, you may have a lot of knowledge, but if you're not able to tell to everyone, like, this is what is happening, that's not meeting the intended goal. So that's what a data scientist skill set is. Moving to the next slide. So let's what data is, what data warehouse is. And I believe many of us might not be knowing like what a data warehouse is. So there is a 4-minute video which is going to give you a brief explanation. What is a data warehouse? Take a look to that.
Data warehousing is one of the hottest topics both in business and in data science. But if you're new to the field, you're probably wondering what a data warehouse is, why we need it, and how it works. Don't worry, because in 4 minutes, you'll know the answers to all these questions. All right, first, let's start with the definition. What is the meaning of the phrase single source of truth? In information systems theory, the single source of truth is the practice of structuring all the best quality data in one place. Let's look at a very simple example. Surely it has happened to you to work on a file and to create many different versions of it. How do you name such a file? Well, once you are done, you often place the word final at the end. This results in having a bunch of files with extensions. Final, 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 final. Or my favorite, really final. Final. If this is you, you are not alone. It seems that even corporations never know where the most recent or most appropriate file is. But what if you knew that there is one single place where you would always have the single source of information? That would be quite helpful, wouldn't it? Well, a data warehouse exists to fill that need. So, what is a data warehouse exactly? It is the place where companies store their valuable data assets, including customer data, sales data, employee data, and so on. In short, a data warehouse is the de facto single source of data truth for an organization. It is usually created and used primarily for data reporting and analysis purposes. There are several defining features of a data warehouse. It is subject-oriented, integrated, time-variant, non-volatile, summarized. Let's quickly go through these one by one. Subject-oriented means that the information in a data warehouse revolves around some subject. Therefore, it does not contain all company data ever, but only the subject matters of interest. For instance, data on your competitors need not appear in a data warehouse. However, your own sales data will most certainly be there. Integrated corresponds to the example from the beginning of the video. Each database or each team or even each person has their own preferences when it comes to naming conventions. That is why common standards are developed to make sure that the data warehouse picks the best quality data from everywhere. This relates to master data governance, but that is a topic for another time. Time variant relates to the fact that a data warehouse contains historical data too. As said before, we mainly use a data warehouse for analysis and reporting, which implies we need to know what happened 5 or 10 years ago. Non-volatile implies that the data only flows in the data warehouse as is. Once there, it cannot be changed or deleted. Summarized once again touches upon the fact that the data is used for data analytics. Often it is aggregated or segmented in some ways in order to facilitate analysis and reporting. All right, so that's what a data warehouse is, a very well-structured and non-volatile de facto single source of truth for a company.
So that's what
Data
so that's what the
warehousing is
data warehouse was about. So that gives a pretty much explanation what a data warehouse is. So data warehouse, you can think of all the data being stored at a common location. It's more like, your secret folder where you keep all the relevant data, and every organization has it so that they can do some reporting based on that. And these are referred as traditional methods. When we say traditional methods, this is what they were using from decades. So in order to simplify that, just take an example. You go to a bank, you ask for some reports, like you wanted to know what is your last month or last year or last 3 years banking pattern was, like how much deposit you made, how much you withdrew, and all those information. So you go to a bank, you ask them, and then what they generally say, please come tomorrow or come after a few days. So what happens? What they do is they do have something called OLAP systems, something called online analytical processing systems, where they keep the data in data warehouse, and it takes time to get the data from that data warehouse. Now, in terms of your current data, that is OLTP system, which we currently uses, that is online transaction processing systems. Your current savings account, checking account, all those accounts are readily available, but that data is very small, and that's how it can reside in the system in the bank, which is local to the bank. In order to explain that, so what it happens is how our OLTP data gets into the data warehouse. So on an everyday basis, they collect the data. Whenever the bank gets the data, so these two small databases, images what you're seeing, consider those to be OLTP systems, which is operational database. So through a ETL process, an ETL process is extract, transform, and load. And what it means is you will extract the relevant information, you will transform it, and then you will load it into data warehouse systems. And in the data warehouse system, there are multiple departments. So you can see all the small images. The first one being your customer financials. Second one is your loan financials. And it could be multiple departments within the bank, but they will load it. And based on that, they generate reports. So all these data loading to the reporting process, and especially to the data loading and cleaning that process, this is the most important process in the data mining. And generally, this is done by a business intelligence engineer. We also call it a data engineer, which has happened in the past, which we call it traditional systems. But this is something what we know in detail because we are discussing it. But this is what you see in general when you go to a bank. You simply go to a bank, submit a request, and next day you get the report. So this explains what happens. But what is happening in the background is this. Now, in order to explain the same, like why a data cleanup is important, I do have another video, which is a 3-minute video, and I will explain you in step by step, like why it is important, how it is happening, and a data engineer, how they help us, clean everything. And this is very common, and we have taken an analogy which is compared to food processing. Like every day we cook food at our home, so it is in very similar terms. So let me explain you this. So it will start with the question, what exactly do data warehouses and business intelligence do? And this video is going to clear some things. So taking an example, if data was food, you will find it everywhere. It can reside anywhere. So think about a scenario where your food, when you're preparing something in your kitchen, obviously there will be multiple plants, there'll be some processed food, there will be eggs, and it come from anywhere. That's what this video depicts. Let's move forward. Now, it exists everywhere, but how to retrieve them and when to retrieve them. So obviously, if it is not required, you do not pluck a plant, you do not pluck a fruit. You will pluck it only when you really want to eat it or you want to cook it and when people are hungry. So in this section, they are talking about how to and when to collect it. This is an important part. If you remember, there could be some data which supposedly you have put it somewhere where it cannot be retrieved, and because it's not fit for consumption. Take an example, something which has been trashed, something which fell and became dirty and which cannot be cleaned. So we cannot retrieve in the similar manner some data if it is deleted and it's non-existent. Now, what happens once you collect them? Just like food, it's not that you collect it and you'll be ready to consume. Obviously, not everything can be consumed. So we cannot eat them. We have to process it. And it goes in the similar lines with data. And if you try eating some, you won't like the taste. Some things you cannot eat, and something will really hurt you. This stands for data, and that's where the data engineers comes into picture. What they do for us, they are like chefs. They cook stuff. So now, what they are going to do here, they are going to, segregate or distinguish each bucket. And why it is important? It is a very simple logic what we take, and in our day-to-day life, if we don't know what is put where, we cannot cook our recipe. And think recipe as an analytical reports or analysis what is being shared. So here we are segregating it, what is required, what is food, and what is not food. We examine it so that it should not be having contamination in it, and it goes same with data. We clean it, we make rules what goes where so that we can easily retrieve it. And it could be a scenario where you have been asked to cook food for 10 people and you started your preparation, and the things are changing, so it's not viable to do that. So we have to put a stop to that. Even when the food is getting out, we have to raise some alerts. It goes same with the data, because if it keep on changing, you won't be able to do that. That's how the traditional methods used to work. Again, you can see here it has been an addition. The more and more data is being added, and you don't know how much it should be. So once we define what we are talking, what scale, what we are doing, then only we can proceed further with that. Now, the question is, everything was going good. Traditional systems were doing perfectly fine. So what is the big data and what's the problem? Now, this picture gives a very detailed overview what is happening. Every one of us uses mobile phones, social networking sites, even health trackers. What they do, they generate data. When I'm speaking, I'm generating data. When you are listening, you are consuming it, but you can understand there is a lot more information which can be processed, like GPS. So we have just, in case of mobile phones, we have 3.9 billion of mobile phones. So you can understand how much data they will be generating. And total data which is being generated on an average day is 463 exabytes. Now the question is, what is exabytes? Let's understand it. So 463 exabyte per day, that's the data in the world is being produced on an everyday basis, which is equal to 4.97 into 10 to the power 11 GB per day. You can imagine just in 1 GB of data, how much time it takes just to get copied. So if you are doing some analysis on that and think about just taking a small portion of it, say 10% of it, it's going to be still very huge. So even on the domain level, it's going to be difficult. So right now, many of us cannot relate to that. The reason being, we have all heard the story of men and the elephant who were blindfolded and they were asked to see what the problem is and what it is. So one of the person said it's a rope, another person said it's a wall, but actually the person who was seeing it clearly, he understood the whole problem because the problem was pretty big. It was an elephant. So we are trying to give you a detail what are we dealing with, how massive it is, and why it is called big data, and why it is a problem. So obviously, you cannot consume everything, and that's what the big data is focuses on. But we are required to process these. We are required to get the meaningful information out of this large data. And what are the different challenges? It does come down the line. In order to resolve these, we do have some big data technologies in place. And with evolution, we have seen they're like Hadoop, Spark, NoSQL, Hive. All these big data technologies comes into the picture. And with help of these, we try to analyze the data and get the meaningful insights out of it. So taking an example, Facebook, on an everyday basis, we are generating so much data, me, you, and everyone. The first day, what we do, we take a look to the Facebook. So what we are doing, and whenever we do some post, whenever we do some comments, we are generating data. So indirectly, if you see, we all are working for Mr. Mark Zuckerberg. So he owns it, but we are the workers who are generating data for him. Move the next slide. So let's understand in a more animated manner what a big data is, what the problem is, and this will give you a very nice and a clear picture what I just talked about.
So we constantly produce a lot of data, for example via social media, public transport, and GPS. But it goes way beyond that. Daily, we upload 55 million pictures, 340 million tweets, and 1 billion documents. In total, we produce 2.5 quintillion bytes a day. That's a lot of zeros. It's ridiculous. We call this big data. But what's actually more important is what you can do with it. To process big data, you don't need huge computers. People work with the cloud, an endless network of normal servers, and powerful algorithms. This way, they can analyze over 1 million pieces of data in minutes. And the result? Well, for example, video streaming website Netflix analyzed the big data of their viewers, like popular shows and watching patterns. This way, they produced a successful series with the perfect combination of actors, directors, and storyline. Right now, the big data of traffic is being analyzed to develop a car that can drive completely accident-free all by itself. And in the future, we can even use the big data of DNA to determine the perfect treatment. This way, curing genetic diseases like cancer would become much easier. And that's just the start.
So now we understand what the big data problem is, the amount of data which is being generated. Now the question is how to tackle those. So data can be divided into 3 categories. One is structured, unstructured, and semi-structured. So structured is like everything is cleaned up and it's readily available, just like a processed food. And this resides in the database. Unstructured is which requires cleanup, which requires complete cleanup, just like a raw food. And semi-structured is which is partially cooked, but still it needs to be modified. This is one of the great properties of big data, and you can Google it out. And the first 4 V's which will come. This is one of the V's of the problem of big data. And the question comes, how can we ingest and analyze different types of data together? Second one is velocity, the rate at which it is being generated. You have different sort of data, and the way it is generated is very quick. So just now we understood like the amount per day is being generated is too much. So how to consume that? Next one is veracity. Veracity, when we say, how do we know whatever is being produced is accurate for our analysis? And that's what the analogy I was taking, like how we are knowing from an email which subject line or which line to take and which is for our reference. Because it will be something which will be, it's a waste, we can say. It may be a waste for us, but not for everyone. Next one is value, the most important part of it. We have a lot of data, got it. We have everything set up, but what value we can achieve, that's what the most important part is. At the first, glance, we take a look to these 4 V's and we can figure it out, like why can't we handle it in, divide and rule policy and handle one at a time. But big data has a property like everything changes altogether, and that's how it looks like. If everything is changing at a random speed, obviously it is difficult to manage, and that's what the big data talks about. Now, there is something which is called NoSQL databases. We have all gone through what a database is. Everyone knows like it's a passive repository of data from where we can get the details and all those details. But there are multiple things which has been introduced in the big data, and these usually existed much before that, but we have not focused on that to figure out what a meaningful insight we can get it. So there are different types of NoSQL databases which came into existence, that is document, graph, key value, and white column. And here you can see we do have specific examples. For document, we have MongoDB. A graph is Neo4j, key value, and white column. It has a different use case scenario, but the most important one is being the graph, and I will be discussing a bit more in detail. The reason being, we use this on our everyday basis, so it will be much easier for you to connect to that. So the graph database, it's a very simple example of LinkedIn and Facebook's. We all use Facebook. So what happens is, whenever there is a connection which is happening, taking an example like a friend request is being requested to someone, then sometimes a recommendation comes up saying this person is a mutual friend and they do have some friend suggestions. So what happens there? What happens there is it gives a recommendation based on the relationship between the two entities. So taking an example, I have taken an example, the right side of the corner. So there are two things, vertexes, which is defined in blue circle, and the edges. Edges are something which defines a relationship. So in order to connect that, a relational database cannot store that information. I won't say it cannot store it, but the information, if you want to extract that, it is going to take much time as compared to these graph databases. And that's how it comes into picture. So taking an example pretty quickly, a company has employees and a company is located in a city. So the entities are turned in as circles. We represent it based on circles, and relationships are put like edges. And this contains the valuable information. So relationship can be easily figured out based on these graph databases. Now, coming back to our original question. You remember those kids? They are still waiting for an answer, thinking like we'll get back to them and figure that out, what has happened. So what I'm going to do is I'm going to walk you through a hands-on session. We do have some data and we'll be talking about that. We'll be processing it. we'll be visualizing it, and then we can answer the question to the kids like, are they safe to go out and play in the lockdown or not? So with this, what I have done, I have taken a Databricks example, and Databricks is a big data analytics platform which can be leveraged to consume the data. And this is, community clouds are free. Anyone can join it with a username, email address and a password, and they can bring their own data out there, but it does have some limitations. And Databricks runs on Spark, which is a ETL processing engine, which is memory optimized. And that's how it is able to consume a lot of data in it. Moving on to the next slide. Sorry about that. Let me go to Databricks. I already have that open, so let me open that. So this is Databricks. Here you can see this is the analytical platform, as I said. And before I move on to that, let me first tell you what we are going to analyze and how we are going to answer the kids' question. Just give me a minute. I'll have to find my file where I kept it. Okay, so here it is. So here you can see what I did. I took a data set from WHO website, which is a recent data, and I pulled that for July 1st, that is yesterday. You can see data is already in WHO with date, and what this represents, the COVID situation in each countries. Countries roll up to multiple regions. It has new cases defined, cumulative cases, new deaths, and the cumulative deaths. So if you see, its data set is pretty huge. And I can keep going, and you can see there are a lot of countries with a lot of data in it. So in order to analyze that, what I did, I ran a cluster. And what a cluster is, if you see, a cluster is a group of servers which runs, and it's like computers which has some computational power. And that's where we execute it, ingest the data, and do some analysis on it. So that's how what we do. This particular workspace is called notebook. And in a notebook, we assign it to a particular cluster. When we say assigning to a particular cluster, it means on what computers will be running it, if we want to understand in a very simple and normal language. And as I said, there are multiple ways to do it. And you can see here, this notebook is supporting Python, which is the most important of the programming languages, what everyone uses. But I know many of us are familiar with SQL and they have started using it. So I am taking a SQL example to understand it in a better way. So I have loaded some data of June 7th. I did that 1 month ago, not exactly 1 month ago, but it's near to 1 month ago. And the reason being, we wanted to analyze and figure it out, like what is going to happen in next 1 month. And at that time, if you remember, India was in a lockdown situation. So let's see. So first we are verifying whether are we able to retrieve the data. So you can see that it's getting executed. So it will come with some records and it will say, yes, everything looks fine. And you have your table ready and you can go ahead and do that. Excuse me. So till the time it gets executed, let me take you to the different page. This is the first thing is like data extraction. So we are able to extract the data. On this data set, we'll be doing it. This is, if you remember, our point number 2 in the graph. The first one was finding the business need of it. Second one is what we are going to do. Now, third is data transformation and cleansing. So this data is not complete. So we do have another data set which completes it. And obviously we did do some transformation and cleaning on the data. Next one, we grouped those two data sets together. And then we came up with a map, and the map will show how many cases were there at that time, how many new deaths were reported at that time. You might be wondering how this data is able to help us to answer the kids question, and you will see that in a while. And then we have taken that into WHO regions, what region goes where. And I have also compared two things. One, India, which is a country, India, what we have compared, and with USA. The reason being, the USA was the epicenter, which is currently still is the epicenter. And India, obviously being the home country, we would like to see how it's happening. So this is the relevance what we are taking. You can take any other country. Taking an example of Bhutan, which is our neighboring country. Let's figure it out. What is the trend, what we are seeing in Bhutan's COVID? So here you can see the number of deaths in Bhutan has been 0, but number of cases has increased stepwise. You can take any of the countries based on the data, so you can do an analysis based on your favorite country, or you can say based on your target country. Even if you take for Australia, it will tell you like how it is being done. So you can see, not only on the world level, we can go much detailed on country level, and if data is available more and more, we can do this. Now, coming back to the question, we have everything here, we got it. Now the question is how it's going to help us to answer our kids' question. Now, let me explain you. So this is if you see, this is the same presentation what I have just shown you. So you can see on June 7th, this data is for June 7th. If you see, it's focusing on United States, and the current new cases which has been registered is 1.8 millions near about. Total deaths were 109K. Now, again, for Brazil and all those areas, whatever you want to take a look to, you can simply go in detail and figure out which country is having what, how they are doing, anything. And it has to be supported by the recent data, which has been provided by WHO. I won't say provided, we got it from WHO. Now, what is the important part? This graph is going to be very important. As I said, data scientist needs a skill set of statistics. So once you understand statistics, you'll be able to answer a few questions. And here WHO regions are defined as East Mediterranean, Europe, Africa, America, and West Pacific. The two lines, green and red, are the most important one. And I will tell you why it's the most important one. If you see the cumulative deaths as compared to the cumulative cases, what you will see is in Africa, initially the number of cumulative deaths were increasing as compared to the number of cases. What does this depict? And later, the number of cumulative cases and deaths started stabilizing. So this means in poor countries, say like Africa continent, as the health services were not pretty good and the immune system of the people are not pretty good, they might be malnourished. There were increasingly number of cases, but after a certain time, it started stabilizing. And if you take an example of America, what's happening is initially it went on a straight line, which means as compared to number of cases, there were equivalent number of deaths or a particular ratio was defined, but slowly it got sparse, that it decreased slowly. So this gives a pretty good understanding, like they do have a better healthcare system, and that's what they are able to reduce this, but still it is following a linear approach. Now, comparing our data with India and US, how we are doing as compared to those. So if you see till June 7th, and as per basic mathematics, we all know the equation of a straight line, which is y is equal to mx plus c. So this is pretty linear. Number of cases is increasingly at a steady rate, and number of deaths are also increasing at a steady rate. So this is what USA charts says to us. Now the important one, our home country, India. If you see, starting from March 22, there is a steep in new cases. And we call this exponential in statistics. Exponential is if a one value increases, the other drastically changes. And that's what you're seeing. It's not linear, it's shooting up like a star. But if you see the relevant depth, it is not very high. What does it mean? It points out two different things. Number one, healthcare facilities in India is better than US, but I don't really believe that's the case. But yes, we are pretty good. That I agree. But immune system, if you see here, as the number of deaths are less, we can figure that out. Immune system of Indians are much better, and that's the reason we are seeing lesser mortality rate. So we do have this data set completely for June 7th. And at that time, when the kids came and asked this question, should we go out and play? So now we have different regions. And you remember there were 7 continents what we were talking about. So obviously, if you see West Pacific region, it has more cumulative cases and lesser deaths. So we can assume still not very good to go out, but kids in these areas are in a much better position and less susceptible of getting COVID. But if you talk about the African region, they are more and the mortality rate are more. So what answer we should give to the kids? Every region has a different impact. So we can tell them it's a lockdown period. Yes, you cannot go out, but for especially for West Pacific region and the orange line, Europe, and the blue line, we can take some precautions and they are good to go and go out and play with some protective measures on, but not for America and not for Africa, because the chances are much more that they will get COVID. Now, second most important part, talking about the India's perspective. On June 7th, you can see the number of deaths are very low, but the number of cases was very much high. Now, the problem here is, or one major area where I would like to focus is, this represents the data in a lockdown. Data at that time, India was in a complete lockdown, and the data was, the new cases were increasingly rapidly. So now we can understand with the lockdown, if the people are getting infected is exponential, what is going to happen once the lockdown is lifted? And that becomes our major concern. So we predicted once the lockdown is lifted, there will be more and more cases. And it could happen like there could be more and more deaths as well. Though the immune system is fine, but we are not immortal. And in order to do that, yesterday I again pulled the new data, and this represents July 1st data. And here you can see the number of cases for July 1st has increased. And now you can see the Latin America countries, that is Brazil, is going to, its cases are being increased, and it could be a next epicenter. Similarly, India cases are increasing as we predicted. And now within a month, with the lockdown lifted in certain certain regions, we see we have just double the new cases, and number of deaths has increased by 2.5 times. So you can relate to that. We already predicted that 1 month ago, like if you live the lockdown, this is what is going to happen. And our prediction is getting true. Similar goes here. If you talk about the regions based on the same data set, here you can see now Eastern Mediterranean is also rising up. The graph is changing. So we need to focus on that. Okay, so coming back to the Databricks portion, this is something important and I would like to discuss that. So give me a minute, please. So this is one of the findings which we did, and it's not that this is the only findings what can be perceived. Based on our data, you can run the analysis and analytics on different countries, different regions, different death ratios. If we have data for gender wise, we can also drill it down, figuring it out what has been done, what can be done, who is getting more impacted, who is not getting more impacted, what are the ratios. So all these can be done, and that's how this is a great analytical platform, and I will encourage everyone. This is completely free. You can go start doing some hands-on, choose the language you want to. You can simply click on that. It will give you an option what language you want to choose. If you want to go with Scala, SQL, R, it will give you the flexibility. So we have answered the question to the kids, but it's specific to different regions. That's what I would like to say. Let me go to the next slide. Okay. So far it looks pretty easy. I do understand, like, it looks pretty easy. Like, we have a data set, we did that, and we do understand what can be achieved out of it. And it looks like it's not very complex. That's what you can see in the second point, but that's not always true. You would be amazed to know there is a shortage of data scientists all across the world. This is a very highly paid profession worldwide. You can get a lot of money doing this analysis, and these are, considered to be most professional jobs, most respected jobs. But the point is, the visualization what you have seen right now is just the tip of the iceberg. This is what you have seen, and this is what people see. But ideally, if you take a look here, we have worked very hard to show only this use case. So you'll have multiple failures when you are doing the data analysis. There will be a lot of hard work, and there has to be passion. So this particular profession is more passion driven. So I hope this helps you out. And this is just the beginning, I will say. It's totally depends on every individual, how they want to perceive it, how they want to move forward from here. But this platform is going to give you a good sense of what you are doing as a data scientist, what your careers are in data scientist. That'll be all. So now I will open the question and answer session, and thank you so much for joining. Back to you, Professor Veeru Rajak. You can take it from here, and I will be addressing the questions if they have anything.
Thank you, Neeraj, for such a wonderful and information session. The way that you have explained the data science is really awesome. Really, it's a very difficult to live demonstration in any live program. You have done perfectly. The beauty of this session is that your earlier prediction data based on data analysis is matched with the actual data. Hope your predicted data based on current data analysis may correct. So I request to all the participants to stay at home to protect ourselves from corona. For notes, next segment, that is, we have a question answer session. Neeraj, I will help you to pick up some questions, and I think you will be happy to reply these questions. Okay?
Sure, please go ahead. I will try to make it as simple as you can. As Sir Einstein said, if you cannot explain that simply, you don't understand it well. I hope I have understood the data science well, and I will help you.
There is a question from Anubhav Datta. With the problem of security and so much data, how can we safely store our data?
Yes, so that's a very good question. So as you've seen in the demonstration, like, we talk about cloud, right? So every organization takes its protective measures. So right now there are some platforms taking Databricks. So they do have their own security feature. We need not to worry about that piece because there are companies taking care of that. Azure and Amazon, that is AWS, they do take care of that. When we talk about on-premises data, suppose you have a server, and when we say on-premises, like, it's backup in your server. So obviously there are multiple ways to do it by encrypting it based on special algorithms, and there are major ways to do it. So I hope that I answered the question.
Yes, sure, Neeraj. There is another question from Tuhina Subra Panda. How big data and AI work together? Is there any security for the massive data? There is the same question again, but addition to the security purpose, he added, Tuhina C added, how big data and AI works together?
Very good question. So take an example. AI, as I said in the initial presentation, I explained the relationship between the AI and the data science. How big data relates to that? See, taking an example like sensors, satellite data, which is being produced on every day at a random speed. If you want to analyze it and then you want to feed that to computers, how to take that artificial intelligence, machine learning, which is a part of it. So it will relatively help them to understand multiple scenarios. Just take an example. Um, and this is a very practical, very easy example to understand. A 3-year kid, the way he grows up, he understands it, right? And this is what they say, based on your experience and your timing, you will get to know what things are happening. So if we give multiple use cases, and obviously big data can provide a platform to that, in the AI, it will be helping them to understand how to implement all the use cases. And obviously big data can do that. So that's how it helps the AI to tackle multiple use cases, multiple scenarios where they can leverage it. Does that make sense?
There is another couple of questions from Suman Chakravarti. Can we use Octave for the data science purpose?
I'm sorry, can you come back?
Can we use Octave for data science purpose? Octave.
What is Octave? I'm not aware of that. Can you clear that question, please?
No, just he has written, can we use Octave? There is another question. What is random forest?
Okay, these are some regression models which is used in machine learning. Based on that, you can do some clustering, and that's what these machine learning algorithms are called. K for clustering, random forest, all these are classification and regression models.
There is one question from Suman Chakravarti. Harvard Business Review dubbed data scientist the sexiest job of 21st century. I think you are doing the same job, Neeraj, data scientist job. But beside of our regular expensive bachelor courses, that is, most of the students are here BC and computer science, BSc computer science.
Mhm.
So their concern is it is quite impossible to learn the data science through the paid version.
Paid version, when you say, what do you mean by that? I didn't get that.
Suppose you have to pay some enrolled in somewhere and do some data science.
Yes, that's a good question. Like, one thing comes into picture, like what skill set or what academic qualification is required to be a data scientist. That is one of the major thing. Yes, masters is important. Bachelors can also do it. Even PhD is preferable. So we have a lineup, we can say PhD, masters, and bachelors. And then it depends on your skill set and experience, how you're going to take it forward. So obviously, that's what the degree order is, which I just mentioned.
One more question regarding what is the scope of this data science?
Scope in terms of
in the job opportunities. Yes,
job opportunities.
Yes, Neeraj.
If you have that tag on you, like you're a data scientist, you are going to earn a lot, and that's the hot cake in the market. So you will be the most valued person in the data industry. So it has beautiful job opportunities.
There is one question. One participant who is from US also. He is working in Amazon. He asked a question: how does cloud scale along with the volume of data?
There is a feature of auto scaling, which is just like taking an example of the Databricks. Like if you have more and more data, it auto scales based on your load. And this is something which can be done automatic based by the providers, as well as you can also set up something if you're using on-premises. But generally it is used in cloud, and that is auto scaling, which is enabled.
Okay. I think we have done for the question and answer session. Thank you, Neeraj, once again. I would like to thanks. I would like to thanks all the participants present with us, our vice principal sir, our IQSC coordinator Dr. Samuel Seth, the webinar coordinator Dr. Pradeep Ghati. The idea I am getting to do this from, he is the originator of this program. Mr. Ghati, thank you for this. Our team members, Subhasis Ghosh, Subhadeep Ganguly, and Savik Sadhu. In addition of this webinar, I do have a wonderful news to share all the BCA and BC Computer Science students. Our university, Kaji Nazrul University, has introduced a master program in data science. That is MSc in Computer Science, a specialization in data science from this academic session. With this curriculum, we are providing a platform to students and interested candidates to take a leap in the data science domain. As you know, with the great protest in this domain and the job opportunity, it's a great initiative as well as providing educational and platform for all. I would request everyone to step forward and take the advantage of new opportunities. And in the last segment, I would like to invite our IQC coordinator, Dr. Samuel Zed, for the vote of thanks.
Thank you, Bidu. Am I audible?
Yes, sir. Audible.
Okay. Good evening to all the participants in this webinar session. As a coordinator of Internal Quality Assurance Cell, and on behalf of my institution, Asansol Girls College, I'm proud that Computer Science and Computer Application Department have successfully organized this one-day webinar on data science, big data analytics. I express my sense of gratitude and thanks to our distinguished resource persons, Mr. Neerav Singh, software engineer, USA, who took out his valuable time and blessed us with such excellent presentation and clarified all our questions and also made the webinars interesting, enriching, and meaningful. Heartiest thanks to our Vice Principal, entire team of Asansol Girls College, who had specially mentioned the webinars called convener, coordinators, organizing committee members who have worked hard organizing these webinars. And I am happy to express vote of thanks and congratulations to all the faculty members of my institution, faculty members of neighboring colleges, students, professionals for the active participations in the webinar sessions. Again, thanks to all. Thank you.
Thank you, sir. The feedback form is, we will open the feedback form within 1 or 2 minutes. So kindly fill up the feedback form to get the certificate. Okay, thank you all.